Alright guys, welcome back to my channel. Okay, so this problem here has a lot of moving parts, but what is actually the ultimate goal? So the ultimate goal here is to find the area of polygon ABCEA. Questions like finding the length of BC and also the measure of angle DCE. Okay, so I actually encourage y'all to pause the video and see if you can actually solve this problem before watching me produce the solution. Now, if you're still here, I assume you're ready to go. Okay, so first things first, let us find the length of BD right here. Okay, so we can find the length of BD because we know what BAD, right, is 30 degrees, right? And we know that this angle here is 90 degrees, right? We can use the 30, 60, 90 rule for triangles to find the length of BD. So we know that AD, right, is equal to 60 meters. Therefore, BD is going to be equal to 60 over root 3. Now, if you remember using the 30, 60, 90 degree rule, you can actually see this through constructing one of the triangles here for the 30, 60, 90 degrees. So you do here is x for the base. Here it will be what? X root 3, right? And this is what? 2x. And we know that this is what? 30 degrees. And this is what? This is 60 degrees, right? Okay, so now if you compare this triangle, right, with this triangle, now you can see from the orientation that BD is actually equal to 60 over root 3. All right, so now that we have found that, let us find what BC is. We can find what BC is by applying Pythagoras' theorem, right? So we know that DC is also equal to 60 meters, right? Okay, so by applying Pythagoras' theorem, we can find BC. So BC now, by applying Pythagoras' theorem, we see is BC squared is equal to what? 3,600 over 3 plus 3,600, right, which is equal to 1,200 plus 3,600. So this is equal to 4,800. So now where did I get this from? So this is from the length of BD. And this is from the length of DC, right? Because this is what? 60 over root 3, as you can see here, right? Okay, and then DC, right, is the same as AD, and this is equal to 60 as well. Okay, so by formulating the square of BD and the square of DC, this is how I got these numbers down here. Okay, so now BC squared is equal to 4,800. So now BC is equal to the square root of 4,800. So this is the same as BC is equal to the square root of 1,600 times 3, which is going to be equal to what? 40 root 3. Okay, so now we have found the length of BC. Now let us try and find the angle of what? DCE. Okay, let me draw a line here because I don't want things to start getting messy. Okay, so we found BC. So now let's find DCE. Okay, we know that the measure of angle DAE and angle DEA is right. So now, what would be the angle ADE? So this is just simply 180 minus 15 plus 15, right? Which is going to be equal to what? 150 degrees. So sum of angles on a straight line is equal to 180 degrees. So therefore, angle D right here, right? Angle D, right, is going to be equal to 180 minus 150, which is going to be equal to what? 30 degrees. Okay. So, if you look at the question, you know that DE, right, is going to be equal to what? AD, right? You know this because these two angles here are equal. So it's an isosceles triangle. So if those two angles are equal, then AD is equal to DE. And if AD is equal to DE, so DE is equal to what? 60. So if AD is equal to DE and is equal to 60 meters, and we know that this right here is 30 degrees, right? And we also know that DC is equal to 60 meters. So then therefore, the angles here at the base, right, let's call this X, right, will be equal. So now to find angle DCE, is going to be equal to 2x plus what? 30 is equal to 180 degrees. And then therefore 2x is equal to 150 degrees. And then x is going to be equal to 75. Okay, so now we have found length BC and we have found angle DCE. So now next what we want to do now is we want to be able to find the area of polygon ABCEA. Okay, so what I recommend us doing, right, is finding the area of find the area of ABC, right, plus the area of what? ACE. Okay, now we have a problem here because yes, we can find the area of ABC, but how do we find the area of AE? Since we don't know what CE is, so we need to find CE. And in order to find CE, we're given that area of DCE is 900 meters square. So we can use that information to find the length of CE. Okay, so let's do that up here. Okay, so half base times height, and then what's the height? The height is what? DZ, right? So DZ is 78, so then that's equal to what? 900. So now the base now is equal to 900 over what? 29, right? It's 29 because the height is 58, right? So now the base now is equal to what? 31.04 approximately. Okay, so let's keep this in mind here for length what? CE. Okay, so now we have length CE, and now we can try to figure out what the area of ACE is. So let's do that down here. So now area of ACE, now that's going to be equal to what? Half base, which is 31.04, times the height of the triangle. Whoa. Okay, we don't know what AE is. Okay, we can apply Pythagoras theorem, right? Because we know that the triangle itself, right? AE, right? C, it's perpendicular, right? So AE is perpendicular to CE. So then applying Pythagoras theorem, we know that what? AC is what? 120, right? And then CE is what? 31.04. So now we can find what length AE is. So let's do that. So now this is going to be what? 120 squared minus 31.04 squared, which is going to be equal to 14,400 minus what? Plug that in your calculator, that's 963.5, which is going to be equal to what? AE squared. So now I'm finding this. You see that AE comes out to be 115.91 approximately. Okay, so now keep that in mind. AE right here. And we have CE right here. Okay, so now the area of ACE, so now that's going to be what? Half base times height. So 1/2 times 31.04 times AE, which is 115.91. And this comes out to be approximately 2,708.52. We know that this is 2,078.52. Okay, now let's find the area of ABC. So now the area of ABC, here is going to be equal to 1/2 times 60 over root 3 times 120, and then that comes out to be approximately 1,798.92. Okay, so now let's put all this together. We have this area of ABC is 1798.92, and then add that to the area of ACE, and we have approximately a total area for the polygon drawn by Danny's path to be equal to 3,877.44. And there you have it, guys. So that's how you would solve this problem. I know it's a long problem, but it's a good problem. So thank you guys for watching. I'll see you in the next one.